Before we get into any of the structure, we have to start at the very beginning. And by the beginning, I mean before the beginning. We have to start with the concept of nothing. The foundational claim here rests on what's called ordinal zero. The argument is that true absolute nothingness, total complete non-existence, is actually a logical paradox. It's physically and logically impossible. Your brain immediately rebels against that. Why can't there just be an empty void? But here's the problem. In physics, a state is considered unstable if any arbitrarily small perturbation, any tiny nudge or microscopic fluctuation, causes the system to evolve into a drastically different configuration. It doesn't return to its baseline. Think of a pencil balanced perfectly on its sharpened tip. It might stand there for a fraction of a second, but the slightest vibration in the air will cause it to fall over into a new stable state. Now apply that rigorous concept of instability to absolute non-existence. Imagine a state with zero informational content, total absolute undifferentiation. No space, no time, no matter, just a perfect void. Sounds peaceful, but structurally speaking, the fatal problem is that a state of total undifferentiation is by definition a specific state. It has a characteristic property, the property of being featureless. The concept of no distinction is itself a distinction. You can't define absolute nothingness without instantly creating a conceptual structure around it, and structure is distinction, and distinction is existence. The void contradicts itself continually. Its own internal logic demands a resolution. This answers Leibniz's famous question, why is there something rather than nothing? The answer is astonishingly pragmatic. There's something rather than nothing because nothing is a self-refuting, intensely unstable alternative. It literally cannot maintain its own non-existence. Now there's a legitimate objection here from anyone with a math background. What about the empty set? Math deals with nothingness all the time. In ZFC set theory, the empty set works perfectly fine. We use it to build up all other numbers. But there's a very sharp line between mathematical formalism and physical ontology. Mathematical formalism meaning the rules we invent on paper, physical ontology meaning what actually exists in the real physical world. The empty set works seamlessly in mathematical equations because it exists within an axiomatic system that already presupposes rules. The container of the math already exists. You can draw an empty box on a piece of paper, but the paper still exists. We're talking about a state where neither the box nor the paper exists. It collapses under the weight of its own self-reference. To visualize this ordinal zero state, think about absolute white light. White light isn't the absence of color, it's the exact opposite. It's the overwhelming superposition of all possible frequencies of visible light perfectly overlapping with zero geometric separation. Before you shine that white beam through a glass prism, it has no distinct, measurable individual frequency. It's total unbounded potential. In the state of ordinal zero, all potential informational forms overlap completely. And according to the first axiom, the distinction principle, if there's zero geometric separation between distinct logical forms, they collapse into identity, which is non-existence. So this internal contradiction, this blinding white light of pure unrendered information, hits a critical breaking point. It can't sustain the logical pressure. It has to separate to survive, which raises the obvious question. If nothingness is a paradox that must break, what exactly does it break into? How does the universe take its very first breath? It resolves the paradox through the very first act of differentiation, ordinal one, the zero-dimensional point, the first binary distinction between existence and non-existence. You have the void and you have a point. And this is where the physics gets shockingly literal. This very first transition, this rendering of a distinction, is identified directly with light. Not a photon traveling from the sun bouncing off a leaf and hitting your eye. The fundamental rendering mechanism of reality, which manifests as light. And accepting this requires a radical reinterpretation of c, the speed of light. Under the Standard Model, c is treated as a cosmic speed limit, the maximum speed at which any mass or information can travel through the pre-existing container of space, roughly 300,000 kilometers per second. But it's always been mysterious why this limit exists, and why it's identical for all observers, regardless of their own relative speed. If you're flying in a spaceship at half the speed of light, and you shine a flashlight forward, the light beam doesn't travel at 1.5 times c relative to a stationary observer. It still travels at exactly c. It's as if the universe actively conspires to keep that speed constant by warping time and space. But flip the script entirely. C isn't a speed limit for physical stuff moving through a spatial container. It's the maximum rendering rate of the geometric buffer itself. It's the processing speed, the specific rate at which the undifferentiated void converts its pure informational potential into actual geometric existence. The speed of light isn't a speed, it's a clock rate. The CPU clock rate of the universe generating spatial geometry just fast enough to keep distinct pieces of information separated. The implication for cosmic history is staggering. It means the Big Bang isn't a historical event 13.8 billion years ago. It's happening right now, constantly. Every single time a photon is emitted from a light bulb in your living room, that is time zero occurring. It's the continuous active process of the zero state making distinctions. And naturally, all of this raises an incredibly important question. Does it contradict relativity? Because if it contradicts relativity, the whole thing is dead on arrival. Remarkably, it aligns perfectly. In fact, it provides a deeper mechanical explanation for relativity's effects. We know from Lorentz transformations that if an object accelerates closer to the speed of light, time slows down and distances contract. If you were to somehow ride a photon, which you can't because you have mass, but following the math to its limit, proper time completely stops. Proper distance contracts to absolute zero. For a photon emitted from a star 10 billion light-years away, from its own perspective, no time has passed, and it traveled zero distance. The emission and the absorption are the exact same geometric event from its frame of reference. You can map this out using conformal compactification, specifically Penrose diagrams. A Penrose diagram is a two-dimensional map that squeezes the entire infinite expanse of space-time onto a finite piece of paper. The boundaries form a diamond shape, and those boundaries are called null infinity, future and past null infinity. They're the absolute edges of space-time where light rays begin and end. The zero state, that void of absolute potential, acts exactly as this null boundary. On this boundary, just as relativity dictates, proper time and distance vanish. Light lives exactly on the seam between the unrendered void and the rendered space-time buffer. It isn't moving through space. It's the boundary of space itself, continuously pushing inward to dilate the geometry. The edge of the universe isn't a wall out in the dark. It's the light currently shining in the room with you. So if c is the rendering rate, what does that mean for EMC Plave? It gives mass energy equivalence a breathtakingly mechanical new interpretation. Energy is unrendered potential, pure information waiting at the boundary. Mass is information that's been completely pulled into the three-dimensional geometric buffer. It's stabilized, geometrically committed data on the hard drive, and c squared, the squaring, is the dimensional crossing cost. You're taking a linear rendering rate, c, which is a one-dimensional sequential process, and you're squaring it to fill a volumetric three-dimensional capacity. In standard textbooks, the squaring is often just treated as a dimensional necessity to balance the units, to make joules and kilograms work out. But here it isn't a math trick. It's the explicit dimensional signature of taking a one-dimensional rendering process and fundamentally embedding it into a three-dimensional geometric manifold. You're calculating the computational cost of converting boundary information into volumetric structure. So we have a single point of data, ordinal 1, rendering at the speed of light. But a single point is pretty lonely. How does the universe build the three-dimensional world we're sitting in right now? That brings us to the hierarchy of ordinals and the dimensional leap principle. But first, recall the distinction principle. Logical forms need non-zero geometric separation. If physical separation drops to zero, the forms merge, their unique data is deleted, and they fall back into the void. A single zero-dimensional point has identity, but it can't interact. Interaction requires two things. As informational pressure grows, the system generates a second distinction and must place a gap between them to keep them distinct. This creates ordinal 2, a one-dimensional line connecting 2 points. And that one-dimensional line connecting 2 points is the absolute birth of time. Once you have 2 points separated by a gap and a finite rendering rate of c, any interaction must take a non-zero amount of time to propagate from A to B. It isn't instantaneous. This lag creates sequence and causality. In standard physics, the arrow of time, why time only moves forward, is notoriously difficult to derive fundamentally. We usually link it to thermodynamics and entropy, but quantum equations are time reversible. They work just as well backwards. Here, the arrow of time is structural. It points in one direction because the universal rendering process is strictly sequential and irreversible. Once the void dilates into a geometry, you can't undilate it without destroying the rendered information, without causing a logical crash. From a one-dimensional line, complexity grows. Points interact, form networks, create relational logic fields. This forces the buffer to expand again, generating ordinal 3, a two-dimensional plane. Flat space. But then the relational data keeps compounding and the system hits a crisis point, a dimensional crisis. The best way to visualize this is a two-dimensional traffic jam. Imagine a perfectly flat, infinite plane with roads drawn all over it. As you add more cars, representing more informational relationships, the roads inevitably cross. On a strictly two-dimensional surface, when roads cross, you have an intersection. If two cars arrive at the exact same time, they collide. In these terms, the topological complexity grows to a point where relational lines of logic intersect. Two distinct pieces of information are forced to share the exact same geometric coordinate at the exact same time. And if they do that, they merge, they lose distinction. The universe experiences a catastrophic logical crash, a cosmic blue screen. To prevent that collision, the system is forced to fold. It generates an additional dimensional manifold. It bends the overloaded two-dimensional plane into a third spatial dimension, ordinal 4, a three-dimensional volume. Because of that added depth, intersecting lines can pass over and under each other like an overpass on a highway. Geometric intersection is avoided, distinctions are preserved. And what's profound here is that what we experience physically as mass and gravity is actually the universe doing this folding. General relativity perfectly describes how gravity works. Space-time tells matter how to move, matter tells space-time how to curve. But it doesn't explain why it curves in the first place. The missing mechanism is this. The three-dimensional folding is mass and gravity. Gravity isn't a pulling force. It points inward, back toward the zero-state origin. It's the physical record of the buffer absorbing an intense informational load. When relational density gets too high, local space has to curve to route the relationship safely. Mass is just the measure of that local informational density. The heavier the object, the more complex its information, and the more the hardware has to warp around it. But if you push that to the extreme limit, what happens when there's simply too much information? You get black holes. Ordinal collapse. Think about a massive dying star collapsing. The three-dimensional informational density skyrockets until it maxes out the local buffer's capacity. The system literally can't sustain the three-dimensional volume without a logical contradiction, so it initiates a localized reboot. It deletes the internal three-dimensional volume entirely and encodes all that staggering complexity onto a two-dimensional surface boundary, the event horizon. And this flawlessly derives the Bekenstein-Hawking holographic principle. Since the 70s, theoretical physicists have been baffled by the proof that a black hole's entropy scales with its two-dimensional surface area, not its three-dimensional volume. Which is counterintuitive. If you pack a box with books, the number of books depends on the volume, not the wrapping paper. Under standard physics, this implies the universe is fundamentally a two-dimensional hologram. But here it isn't a weird quirk of quantum gravity, it's the strictly required signature of dimensional compression. The universe must translate three-dimensional volume into a two-dimensional boundary to save the system. So the universe built three-dimensional space to hold matter. It created stars, galaxies, all to keep its data sorted. But where do we fit in? Where does the human mind enter this massive geometric buffer? To get to the observer, we keep climbing the ordinal hierarchy. The complexity doesn't just halt at three-dimensional space, it generates ordinal 5, which extends the three-dimensional manifold into probability space. The structural foundation of quantum superposition. Superposition gets thrown around a lot in science fiction, usually for alternate timelines. But what does it actually mean in physics? In standard quantum mechanics, a particle doesn't have a definite position or momentum until measured. Before measurement, it's in a superposition of all possible states simultaneously, described by a wave function. It's treated as this mystical state of being everywhere and nowhere. But it isn't mystical at all. It's simply information currently waiting in the processing queue to be rendered. It exists partially in the void and partially pushing into the three-dimensional buffer. So the famous Heisenberg uncertainty principle isn't a limitation of our microscopes. Heisenberg showed you can't pin down both position and momentum simultaneously. Reframed, this is just the mathematical description of the rendering threshold. The buffer hasn't finished allocating the computational resources to render both properties fully at the same time. The information is bottlenecked. And this creates the foundation for agency, the capacity to navigate dynamically between possible unrendered states before they lock into the three-dimensional geometry. From there, it cascades into Ordinal 6 recursive self-reference. The system achieves the ability to model itself. And here's where it gets really interesting for biology. There's a physical anchor for Ordinal 6 in the real world, carbon, the sixth element on the periodic table. It has exactly 4 valence electrons. Those 4 electrons map perfectly onto the fourth ordinal, our three-dimensional spatial volume. Carbon forms a tetrahedral bonding geometry. It's essentially a 4 within 6 architecture. And this isn't a random chemical coincidence. It's a strict structural necessity of the buffer. Carbon is literally the only hardware configuration stable enough to allow the universe's most complex software life, recursive self-modeling, to anchor into the buffer without crashing the local system. Standard biology treats carbon's suitability as a brute fact, a lucky accident. Here, it's derived from the fundamental ordinal architecture of spacetime itself. And this derivation leads directly into the most transformative philosophical shift in the whole framework, the hard problem of consciousness. Formulated by David Chalmers in 1995, it basically asks, why does subjective experience exist at all? You have easy problems, like how the brain processes visual data or moves a muscle, mechanical processes. But the hard problem asks why those mechanical processes are accompanied by an inner life. Why aren't we just biological robots, completely dark inside? Why does it feel like something to see red or taste an apple? Science usually assumes matter is fundamental, and consciousness is this weird ghost emerging from complex brain chemistry. But invert the entire premise. Consciousness isn't an output at all. It isn't an accidental byproduct. Consciousness is ordinal zero. It's the blank canvas. It's the undifferentiated potential absolutely required to register any distinction whatsoever. A physical difference in the universe doesn't actually exist meaningfully unless there's a unified locus of awareness to register it. We are the zero-state awareness achieving recursive knowledge of itself through the biological hardware of carbon. We didn't randomly pop into existence when apes evolved big brains. We are the origin point of reality, looking back out at the geometric hard drive it built. It's an elegant framework. But mathematical beauty isn't enough. Elegance isn't enough. We need hard math. We need observational cosmology. A theory is only viable if it can solve real, currently intractable physics problems, and it must make falsifiable predictions we can test with telescopes. So let's talk about the pressure principle. It states a clear geometric rule. The manifold, the geometric buffer, must physically expand whenever local logical pressure exceeds the geometry's holding capacity. Logical pressure is rigorously defined as the ratio of local information density to the available geometric volume. As the universe generates new relational data, it strains the buffer. To avoid a crash, the buffer literally stretches, expanding its volume to dilute the density. This gives us a fully mechanistic explanation for dark energy. Right now, dark energy is basically a placeholder name. In standard cosmology, the lambda CDM model uses the cosmological constant lambda, but it's a free parameter. We measure the expansion, plug the number into Einstein's equations to make the math work, but we don't know why it has that value. And when quantum field theory tries to predict it, the result is catastrophically wrong. The theoretical prediction is off from reality by 120 orders of magnitude. That's a 1 followed by 120 zeros. It's notoriously considered the worst prediction in the history of physics. Quantum field theory predicts the vacuum of space should possess so much energy that the universe should have ripped itself apart into a fine mist instantly. The fix comes from completely reframing what that number represents. The cosmological constant isn't a math error, it's a highly accurate measurement of the buffer's filtering capacity. The vacuum of space isn't empty. It's the boundary where the intensely pressurized void is actively trying to separate into distinct forms. That massive number from quantum field theory represents the total raw pressure of ordinal zero pressing against reality's boundary. The tiny value of dark energy we actually observe pushing galaxies apart is simply the leak rate, the tiny fraction of surplus logical pressure that the three-dimensional geometry couldn't efficiently absorb into structural complexity, so it bleeds off as gradual spatial expansion. The massive gap between prediction and observation isn't an error. It proves the buffer is working incredibly efficiently, converting raw potential into ordered structure rather than letting it blow space apart violently. It turns a massive problem into a feature. Now, what does all of this mean for the Hubble tension? That's another huge crisis in astrophysics right now. We have two very precise ways to measure the Hubble constant: the expansion rate of the universe. The first method looks at the very early universe, the cosmic microwave background, the afterglow of the Big Bang. We study the acoustic peaks and predict how fast the universe should be expanding today. We get about 67.4 kilometers per second per megaparsec. The second method measures the late universe right around us. We use standard candles like Cepheid variables and supernovae. When we physically measure nearby galaxies, we get a rate of about 73. That's a 7 to 9% discrepancy, and our instruments like James Webb are too precise for this to just be an instrument error. The error bars don't overlap anymore. Standard lambda CDM assumes one measurement must be wrong. But neither measurement is wrong. The tension is predicted naturally. Standard models predict expansion based solely on mass energy density, which should dilute evenly. But if expansion is driven by informational complexity, look at the difference. The early universe was a hot, simple soup of hydrogen and helium, very low relational complexity. Our local universe today has undergone 13.8 billion years of compounding evolution, heavy elements, compound chemistry, planetary systems, biology, recursive self-awareness. The informational complexity has exploded. More complexity equals higher logical pressure. So the local buffer literally has to expand faster today to keep all this new data from crashing. The tension is a measurement of the universe's evolving software load. And there's real math behind this. Using the Shannon entropy of coarse-grained mass density to calculate the information load across epochs, a specific scaling factor alpha comes out at roughly 8 times 10 to the negative 19 cubic meters per second. This isn't randomly fitted. It ties the Hubble tension to the maximum theoretical informational density of ordinary nuclear matter. When you decompose alpha through dimensional analysis, the characteristic length scale lands at about 5 times 10 to the negative 14 meters, right at the nuclear diameter, the femtometer scale. That's the scale where the strong nuclear force operates and where ordinary matter achieves its highest informational density. It doesn't land at the Planck scale, which would suggest quantum gravity. It doesn't land at cosmological scales, which would be trivially uninformative. It lands exactly where the physical universe's information is most tightly packed. That's a non-trivial consistency check. But as we said, we have to be able to test it. We have to be able to prove it wrong. And this is where the framework transitions from philosophy to hard science, with several highly specific falsifiable predictions that contradict lambda CDM. First, cosmological data from SDSS DR17, the Euclid Space Telescope, and DESI galaxy surveys. Standard models predict a region expands based entirely on mass energy density, gravity pulls, dark energy pushes. But here the prediction is stranger. Take two massive regions with the exact same mass energy density, but one region has a vastly more complex topological structure, more intricate galaxy clusters, more complex chemistry. The prediction is that specific region will exhibit a measurably faster local expansion rate. The geometry will dilate faster to handle the structural load. If observational cosmologists comb through Euclid and DESI data and find that correlation, standard lambda CDM is in fatal trouble. Second, the cosmic microwave background itself. Standard inflation predicts a perfectly Gaussian distribution of CMB temperature fluctuations. The prediction here is that we could find specific topological anomalies measured through Betti numbers which count the multidimensional holes in a topological space. These anomalies would be fossilized signatures of the early universe, making that violent phase transition from a two-dimensional relational plane into a three-dimensional volume. Third, gravitational waves from black hole mergers detected by LIGO and Virgo. General relativity says the final ring-down phase of a newly formed black hole depends exclusively on its total mass and spin. It rings like a bell. But the prediction is that as our instruments get more sensitive, we'll see that the ring-down encodes subtle deviations based on the internal pre-collapse informational complexity of the progenitor stars. The geometry should remember how complex the software was before it compressed. And we don't just have to look up at the stars, we can look inside our own heads. Independent corroboration comes from neuroscience, completely unexpected in a physics context. A team at Skulltech used advanced fMRI connectome data to map how the brain encodes memory, how it separates distinct informational states so memories don't blur and corrupt. Through topological data analysis, they found the neural architecture optimally organizes memory engrams into an abstract geometric structure that operates in exactly 7 dimensions. 7. The exact same number of ordinal levels, 0 through 6, culminating in the 7th state of homeostasis that governs the cosmic framework, actively dictating the physical neural geometry of human memory inside your skull. The macro and the micro using the same strategy. Take a second to really think about the scope of this. The mathematical rules stretching distant galaxies apart to prevent a logical crash are the same rules structuring your memory of what you had for breakfast. It bridges the terrifying math of cosmology with the intimate reality of conscious experience. Under standard models, humanity is an accidental byproduct of dead physics. Under this framework, our informational complexity is actively participating in the geometric structuring of spacetime. We are the system achieving self-reference. So we started with the logical impossibility of nothingness, the paradoxical void. We saw it fracture, revealing light not as a speed limit, but as the cosmic rendering engine processing the void into existence at exactly c. We watched early spacetime fold into a three-dimensional geometric hard drive to store escalating data without crashing. And we arrived at consciousness not as an accident, but as the origin point, the zero state anchoring itself to finally know itself. It takes the most perplexing anomalies, dark energy, the Hubble tension, the hard problem of consciousness, black hole entropy, and threads them together with a single, elegant geometric principle. And I'll leave you with one final, deeply provocative thought to sit with. If cosmic expansion is fundamentally driven by the logical pressure of informational complexity, what happens as humanity fully enters the age of artificial superintelligence? If we exponentially explode the informational output of our planet through recursive AI, massive quantum computing networks, hyper-complex simulations, will we generate so much logical pressure on our local geometric buffer that we literally begin to stretch the fabric of local space-time around the Earth? Are we about to empirically test ordinal dilation theory simply by computing too much information for the local universe to hold?